So, polymorphism. So basically, someone said it correctly, but what value does z pick up if this is how you call this function?
0?
Nope, it doesn't get 0.
No.
It doesn't get null.
Undefined.
It gets undefined. Although there's really not a huge amount of difference semantically between undefined and null, right? But so yeah, z gets undefined. So what's 2 times 4?
8.
What's 8 times undefined?
Not a number.
Not a number. So the output of this program is not a number. Here's another question for you. Oh, wait, before we move on from this, I'll show you how to correct this. And this is also an element of polymorphism in JavaScript. If you put an equal sign up here and then give it a default value, then it will default to the value you give it rather than undefined, meaning, well, in the case of multiplication, actually, you probably want 1 and not 0 because anything multiplied by 0 is 0. But if you put a nice kind of non-value in there for whatever operation you're doing, it kind of smooths things out. The result here is now 8. Make sense? So default arguments. That's between those 2 mechanisms. This is how JavaScript chooses to handle method polymorphism. Does anybody remember how Java handles the same thing? How does Java handle method polymorphism?
Overloading.
Say it louder.
Overloading?
Overloading, yes. So when you overload, what do?
You do the same method with different parameters.
Yes. So Java requires you to anticipate every single way in which the function will be used. And it allows you to still say, all this category of things, you're not allowed to do that, right? JavaScript doesn't. You can call a function with any number of arguments, with any type of data supply. This is one of the things that TypeScript fixes, presumably. So, good. Let me show you another one, though. Because if you can get undefined coming into them, you can also get undefined coming out of them. Oh, just gave it away. So, function foo let's say we have let x equal 5, right? X plus equals 10, right? Let y equal foo. What's the value of y after this program executes?
$11?
Well, that's a 5.
Oh, sorry.
That's a guess. That's a good guess, but no.
It is 15.
Undefined. This function doesn't return anything,
Yeah, you're right.
right? Any function that doesn't return anything returns undefined. So the value that y gets is undefined. Make sense? So that's about as much as I will say about polymorphism. Let's talk about lambdas, shall we?
Yes.
All right, so JavaScript doesn't like to use the term lambda, even though that's what they are. They are lambda functions. So basically you have two flavors of anonymous functions in JavaScript. There is only a very slight difference between them. We have the function. Oh, let's give this poor thing an argument. Hey, there we go. Right? We've got those two ways of doing things. Generally in class, I refer to this one as an anonymous function and this one as an arrow function or a lambda function. The terminology that the JavaScript community prefers is arrow function. Generally, these things are fairly equivalent to each other. With an arrow function, you can throw curly braces in here, and it becomes a code block similar to a function, an anonymous function. You can think of this one as like auto-returning, whereas this one does not auto-return, right? So like, you know.
So, what do
Yes.
you mean by auto-return?
Sorry?
What do you mean by auto-return?
So if I say put x plus 5 here,
Recursive?
no, it's not recursive. It just automatically returns the result of x plus 5. Whereas here, if I put x plus 5, it doesn't automatically return the result. It behaves like a regular function. If you want to return x plus 5, you have to say return x plus 5. So when I say it auto-returns, what I mean is you don't need the return keyword. Right? Does that make sense? So that's, you know, basically one of these is built for statements and the other of these is built for expressions. You guys know the difference between a statement and an expression?
That's the thing.
See, this is the thing that you guys should have been taught in fundamentals instead of messing around with the bloody chatbot. So absolute fundamentals of programming now, all right? You've got two different categories of things you can write down. I happened to do my doctorate in programming language theory, and I'm about the closest thing to like a dusty old librarian of programming languages, because like my field of study was the rules that govern the construction of languages themselves. So I know what I'm talking about when I say this. You have two grammatical constructions within programming languages. Come on in. You have expressions and you have statements. Expressions roughly map to, okay, let me pull you all back to algebra, all right? What's the difference between an expression and an equation? Way back to elementary school, what's the difference between an expression and an equation?
I can tell about expression and statement.
Mm.
Statement is like when we write, for example, when we write the function, when we write return x plus 5 and we use a semicolon, that is a statement.
Roughly speaking, yes. Statements are lines in our programming. So when you talk about a line of code, you are normally talking about a statement. Yes. So in algebra, an equation has an equal sign. but an expression does not have an equal sign, right? So x plus 3 is an expression. X plus 3 equals 7 is an equation, right? This is an expression in programming languages as well, right? So an expression, like for example, if I take a look at the function we already have up there, right? Right. This is a statement. It is a return statement, right? This is an expression. So expressions are things that go inside of statements, right? So expressions are, roughly speaking, stuff like that. Also your Boolean operators, right? All of these things, throw in a few extra things like method calls and ternary statements. That's what expressions are composed of. These plus literals and variables. That's what an expression is. Statements are things like assignment, if statements, loop statements, right? Function declarations, return, switch case, switch cases are a statement, break statements are a statement, continue is a statement. You guys get a feeling for these two categories, right? So when I say that anonymous functions are roughly for statements and lambdas are roughly for expressions, what I need to say is, if you're putting this kind of stuff inside of one of these, consider using one of those. Does that make sense? They can do each other's jobs, but should they, they're kind of for different purposes. Any questions about that?
So generally, if it's a calculation or a comparison, it's an expression?
Yes, if it's a calculation or a comparison, it's normally an expression. Another way you can think of it is that expressions are generally reading memory and statements are generally writing memory. And that is particularly true once you've realized that things like if statements are write operations on the program pointer. So when you have a program, there is a thing called the program pointer that tells the computer what line of the program you're on, right? All of your flow control, all of your fancy flow control, are operations to move the program pointer around to different parts of the program. That's what they are. So you can think of this like kind of as write operations on various types of memory, and these as like read and calculate operations as well. That's not a terrible way of thinking about it. Make sense? All good? Yeah. Statements are then in some sense, statements are collections of expressions, and subroutines are collections of statements. Subroutine is like the general term for like functions, methods, stuff like this. Make sense? All right, programming. Everybody like it still, hopefully? It is an actual language. Programming code is an actual language, It just so happens that some of them suck, that's all. Yes, so There is, though, one semantic difference between these two things, and it's non-trivial, but it's a little bit elusive. So I won't bother, trying to get you to guess it. So variable scoping, right? This thing creates a new variable scope. This thing does not. That's an important difference between the two of them, right? So if I have a let binding, and I put it inside of here, it binds to this function. If I have a let binding that I put inside this thing, it binds to whatever the containing scope is.
Can you
Right.
repeat?
It's not really length.
Well, you know what? Let's talk about scoping kind of in more general terms then, and then we'll come back to that. So there are 3 ways of declaring a variable in JavaScript. You guys remember them?
Let var const.
Let, var, and const. Very good. So let's get constants out of the way first. What are they for?
Const?
Yeah.
It's a constant.
Constant.
Like
This is
it
not
never
change.
change.
Yes. So once you've given them their initial value, it disables write privileges, is another way of thinking about it. You just can't write to it. You can only read from it. It really, when you start digging into programming languages, you really should be thinking most of the time in terms of read and write privileges for this type of stuff. It really helps to think of it that way. So const, you can read it, but you can't write it. Sure. Const shares the same scoping rules as let. So can anybody tell me the difference between the scoping rules on let and var?
Var is local and let is
Let is local.
Let is local and var would be,
What is
this
global.
is,
Global. Yeah. Var is global and let is local.
this is a common misconception. And it probably appears in the notes too. This is kind of there's really no such thing as a global variable unless you're talking about constants defined in the bloody kernel, all right? This is actually not true. This is if you ask the stupid chatbot for its opinion, that's probably what it'll tell you because it's a common misconception, right? How is Java scoped? Block level scoping. Let is block level scoping. Var is function level scoping. So just because you define something as a var, that doesn't automatically turn it into a global variable. And you all know this because you've probably all tried it and it hasn't worked. Right? You've tried making making something into a global variable by declaring it var, and you've had to declare it at the top of the file anyways, right? Var is function level scoping. Let is block level scoping. As a matter of fact, if you're at the actual top level of the file, it doesn't matter if you use let or var, though honestly, you should probably be using const instead anyways, if it's defined at the top of the file, right? Not always, but more often than not. So yeah, okay, all right. Okie dokie. Let me give you an example. Let's say we have a function, foo. I feel like you guys are learning a lot about the language right now. That was kind of the point. Here, let me reteach to you in 3 hours the entire first half of the course, the way it should have been. No. Oh, though, when I redo this course, this is exactly the stuff that I'm going to put in the course, Function foo, let's get For let I equal 0, I is less than 10, I plus plus, don't care about the content. For var j equals 0, j is less than 10, j plus plus, that looks like a g, j plus plus, dot dot dot. This is an abbreviation for console log. I don't want to write the whole thing. There you go. 2 loops. One declared with a var, the other declared with a let. Right? If I console log I, what do I get? Undefined. That's right. I get undefined, I don't get a compiler error. In Java, you would not even be able to compile this hot mess. Right? How about this one? What do I get? Well, it would be 10, right? Because on the last loop iteration, when that condition fails, j would need to be 10, right? But you're on the right track. You had an off by 1 error, which is a very noble type of error in programming. Yeah, j would print as 10, right? Because the scope of I, because let gives block level scoping, would be this code block and no further. That is the scope of I. Var, on the other hand, is function level scoping, which means the scoping applies to whatever the containing function is. Like that.
So why wouldn't let work in the scope? Why wouldn't let work in the
Down here?
yeah?
Because it's outside of its scope, right? So block level scoping means loops and if statements as well as functions, right? So basically the local context for this variable is only this loop. Outside this loop it doesn't exist. Does that make sense? So within, good programming practice for people who are concerned about such things, generally you want to use let unless you have a reason to use var, right? Your default should be let because it's just generally useful to have variables restricted in their scope. It's like the reason, like you've probably heard I shouldn't use global variables, but you may not know why you shouldn't use global variables. Would you like to know why you shouldn't use global variables? The reason is that
Like safety?
safety, but also like I almost want to say it's more hygienic to program that way. It provides less surface for bugs to live on. If you wanted to program like absolutely perfectly, you wouldn't use variables at all. Everything would be direct calculations on functions, right? That's not practical. We need some variables, right? But like as you go through and become a more skilled programmer, you'll find you're less and less reliant on variables per se. Now, when you make a global variable, you are setting aside some state that may affect how the program behaves, right? Bugs in global variables, global memory, are very difficult to diagnose. Bugs in the memory of the operating system are very difficult indeed to diagnose. So the basic solution to the problems that global variables introduce is to just not use them. So like, when you're using global variables, you have variables whose values depend not on the calculation of a single function, but how many times has that function been executed in this program? You know, who knows how many times that function's been executed, right? It makes it very difficult to reproduce the memory that caused a bug, right? Functions shouldn't have side effects. This is like the general principle, right? When a function writes to global variables, that's considered a side effect, right? Perfect functions only look at their arguments and only output in their return statement. That is a perfect function. Any side effects are undesirable. You have a question?
Yeah, I just have a question about the scope of J. I think I'm assuming with the big line here, the entire function can access J. If you have a log J before you do your for loop, would it still print out 10?
If I have, sorry, what here, sorry? Say it louder?
Because J is accessible anywhere because it's a var.
Yeah.
If you have a log J above that for loop, would that still print out 10?
Oh, like here, for instance?
Yeah. Because the for loop is after.
Yeah, it's not in scope yet. Yeah, oh, I'm sorry, yeah, I should specify.
Okay, yeah, that was
Yeah.
confusing me for a little.
Yeah, sorry, it's still true that it's only defined after it's been,
Okay.
yeah. I'm sorry I violated causality, you know. I was having variables declared before they were declared. Yeah, no, you're absolutely right, yes.
If you were to recall this function, would it say what var is, or would it create a new var that's scoped to that function? So you know what I mean?
When this function ends, both of these variables go away. Yeah. Both I and j, well, I quite a bit earlier, but yeah, when the function ends, j goes away as well. Yes.
With arrow functions not respecting scope, how does a var behave inside of an arrow function?
It binds to the containing function. So like, for example, let's say that inside here I had, you know, I don't know why you would do this, but let's say you did. Something like that, right? The scope of X breaks out to be the same scope as J. Whereas if this were an anonymous function, you know, keyword function, open, close, curly braces, that would be a new scope for the variable. It wouldn't break all the way out there, it would be contained here. Yes.
Aside from obviously the semantic reasons for declaring something as a constant, is there a memory reason for declaring something as a constant?
Is there a memory reason to declare it as a constant? Well, it binds the same way as let, right? Constants bind the same way as let, so no. It's mostly for safety. It's mostly for safety is the reason that you want to use constants. Like constants are technically unnecessary, right? They don't do anything a variable doesn't do, right? Yeah. Any questions about this?
Like arrow function bind to the next variable?
Does it, what do you mean by the next variable?
Oh no, like I'm just asking like maybe I missed that one. Like arrow function bind to what you say like I missed that one.
Oh, sorry. So the difference between an anonymous function and an arrow function, an anonymous function provides a new function scope, but an arrow function does not. So this thing, if you declare a var, or even a let variable inside of this thing, the var binds to the containing function, not inside of this, right? If you had function, you know, one of these, the binding on f would just be this function. Sorry, f, what am I talking about? The binding of y would just be that function. Whereas the binding on x here breaks out to the containing function. That's the actual semantic difference between these things.
So what is, so the counting function is the j, you mean?
The j is the loop,
Yeah.
right?
So what is, so the arrow function, like what is the containing function here?
Sorry, can you repeat your question?
Like, you said arrow function bind to the containing function, right?
Yes,
So what is the containing function here?
foo.
Oh.
Yeah, if this were a let binding, it would bind to this loop, right? But because I made it var, it binds to the function.
Okay, now I get it.
Awesome.
Thank you.
I think we've probably said enough about lambdas. Typing, let's talk about typing. So I sometimes joke that there's only one type in JavaScript and it's garbage. Everything is garbage typed. There are two important terms that are necessary when we're talking about Java's type system. Weak typing and dynamic typing. So JavaScript is a weakly, dynamically typed language, right? This is in stark contrast to Java, which is a strongly statically typed language. So it's about as far away from Java's type system as it's possible to be. It's a wonder why they even call it JavaScript. So these two terms are commonly confused. What does it mean to be dynamically typed?
Like we don't need to.
Because this one variable can change what type of variable it is, while keeping the same variable.
Yes. So dynamic typing basically means that, you know,
We don't need to declare the type of the variable.
right, when you declare a variable, you don't declare it with a type, right? In Java, you better know the type if you're going to declare anything. In JavaScript, you just say, let it be, let it be this. Yes.
Oh, I don't know if you noticed, but one thing they actually added recently in Java was that you can use var now in Java and it interprets the value.
Yeah.
Oh, really?
Yeah.
Yeah.
Interesting. That seems like that's a thing that should be added to the course. Yeah, see, the thing is, it would still be very different from JavaScript just because of the way the language works. So in Java, it is necessary to know what the type of the variable is because it's calculating how much memory it needs to give it, right? So it's not allowing dynamic typing, it's allowing type inference, right? It can infer what type it's supposed to be, right? Like if you declare a variable and you assign it a string, it's a string, right? That was a string. I imagine it's still not going to allow you to then reassign it to an int, right?
Yeah, probably not.
That would be quite a substantial, I don't know if you could even do that to Java. It would break so much of the existing code, to implement that change in the Java compiler would be a murderous task. It's like the reason other languages exist in the first place is because it's very difficult to change a language with respect to something like that. But some light type inference, like the type checker is already doing that, right? So that's different from dynamic typing. In dynamic typing, you have a variable. Today, you can give it a string. Tomorrow, you can give it a Boolean. The day after, it can be an object. It doesn't care. It doesn't care what you assign to it, right? There's no enforcement of typing on variables. That's what it means to be dynamically typed.
So then how does that work with in memory,
Um,
JavaScript variable?
so the closest thing I can figure out is that every variable in JavaScript is probably encapsulated by a pointer, right? Pointers are all like all memory pointers are the same size, so you can allocate them. You always know how much memory to allocate to them, but you then declare a region of memory that the pointer is pointing to. That can be a variable size. You can adjust it, okay, all right.
Is it like a list for saved memory in Java?
It's like a list. It's like every variable is a list containing one element. So like you have your pointer to like say the string hi, right? In JavaScript, if you want to assign this to something of a new type, you just make a new node for like 5, reassign the pointer, and send that off to garbage collection. It looks like, oh, I can just assign an integer to it, and it's fine. It's an integer now. It's like, yes, because it's doing a fair amount of encapsulating things, right? And I am convinced that the way that JavaScript works, without it knowing the internal detail, is that they also, somewhere in that thing, they tag it with the thing that it is. I'm pretty sure that's how it works. Because then, that kind of leads us into our next topic. What is weak typing?
It's like equal, like 3 equal and 2
Yes.
That's what I was gonna say, where you can be like 5 in string can be the same as 5 in.
Yeah.
Very good. So, JavaScript has 2 equality operators. Weak equality. You're bad equality. And you have strong equality. So under weak equality, that comes out as true. One way of thinking of it is that this thing is attempting to do some light type conversion. I'm convinced that what it means is it's comparing these but not these, right? Strong equality, this would result in false. Under strong equality, you kind of check the type first, and if the type is mismatched, then you just return false. Otherwise, you compare the values, and if the values are the same, you return true, right? So it's kind of like, I'm convinced, even if it's not how it's actually implemented, it's a good mental model of JavaScript, is like, you should think of everything being tagged with its type, and then it's like actually comparing the tags before it compares the values. That's how strong equality works. So, yeah. PHP is also weakly typed, and also dynamically typed. So, that language sucks too. That language sucks because every single variable that you write in PHP has a $sign in front of it. Every single one. You have to type the $sign every single time. It sucks. PHP is a language that hates you. Although JavaScript hates you more. If there's one language that hates you more than any other language, it's JavaScript. So, good. Any questions about typing? Okay. Good. All right. I feel this review session is best served if it's focusing on the first half of the course, because it's been the greatest amount of temporal distance between here and there. Like we just did Ajax last week. We'll cover it if we get to it, but that is not even close to the time. What? It heard me. The clock's just kind of like what? Somebody look at me.
Yeah, it's been doing it all semester, I don't know why.
I thought it just is 12, so
Yeah, some days switches look, I'm like.
18 wasn't even.
I mean, that's actually a reason to like submit a ticket to thingy. Yeah, if a clock is broken, like they have more, they can just replace it. Presumably they have more. All right. Shall we talk about client server stuff? That'd be a good thing to go through. So, the basic thing that's like the important thing to get across here is how does the communication cycle work, right? Now, there are like two main answers to how does the communication cycle work. One of those is the answer that you got in intro networking, which is like the TLS handshake is how this works, right? All of you have chosen your field, all right? You have chosen, for better or worse, software development rather than networking. I have absolutely nothing against the networking guys, right? They are cool people who do cool stuff, mainly using Linux, which I really appreciate. Also, like, it's kind of interesting, like networking versus software development. It's like a lot of people kind of on those two sides feel that like, oh, I have no idea what those other guys do. But like, if you start digging in, like a good networking person is a good programmer, and a good programmer definitely has the ability to be a good networking person. You know, it's the same skill set, the same particular type of mental damage that makes you good at computers that's necessary on both sides, right? It's just, you've studied a different domain. You could easily pick up networking stuff. They could easily pick up this stuff. That's the difference between us, right? Between us and networking. But anyway, the networking answer is like, generally like, how do routers work? We don't care how routers work, right? All we care about is the endpoints of the communication, right? So, the two endpoints of client-server communication are, not a trick question.
Client and server?
Client and server, that's right. Client, as normally represented by an antiquated CRT monitor, and server, which is normally represented as a box with some blinky lights, because that's what a server is. So, question: who initiates client-server communication? The client, yes. The client makes a request. How many times does a server connect to a client? 0 times. It never happens. Servers never initiate connections. They never do it. Not even once. I know that seems basic, but it's like one of those basic things that like you really have to like understand and like absorb into your body fat reserves. You know, like you really have to know that clients always connect to servers and not the other way around. You can't really, like, you will not survive server side unless you fully ingrain servers do not connect to clients. Clients connect to servers, right? So, all right, so let's say that our poor client over here is requesting a web page, right? Request for index.html, right? We haven't gotten to, like, we've touched on APIs, but we haven't really like dug our hands into it yet. For now, we should still be thinking about internet communication as essentially a great big distributed file system, right? You have the client, it sends a request to a server for something, right? The thing it's requesting is a file, right? File servers, right? Again, APIs, that's a different bag, that's a different kettle of fish, but that infrastructure is built on top of this one. Fundamentally, request packets are requesting a resource, right? It's hypertext transfer protocol. It was designed to transfer hypertext. So, we are requesting index.html. The server has a file system in which the file index.html exists. Right? So it says, oh, you'd like index.html? Well, okay. Responds with index.html. Right? Now, once the browser receives index.html, it begins parsing it. You guys know what the word parse means?
Reading?
Yeah, essentially. To convert from a string into something else. So we parse a file to produce the objects in memory that form the web page. We also parse a string to get a double or an integer out of it, right? We parse source code so that the compiler can compile it. Parsing is like the first stage in pre-processing is the first stage in compilation, but once you've done pre-processing, the next stage is parsing. So, the file gets parsed. The way that the file gets parsed is important, right? How does a browser load the contents of an HTML page? How does it load it?
It works through the DOM elements,
It works through the DOM elements how?
top down, like HTML.
Yes. So it starts at the top, and it reads DOM elements into memory, one at a time, as it encounters them, as it goes down through the file. Right? When is JavaScript executed?
When it's encountered.
It
it's
depends
converted.
on,
When it's encountered, what were you going to say?
I just wanna say it depends on if you use like defer or not.
That's right. But assuming that we've not used a defer tag or, well, let's assume we haven't used a defer tag. JavaScript is executed when it's encountered, but does the JavaScript come in the initial load of the HTML file? It does not. It requires another request, right? So this is how it works, right? This is also the case with style sheets, right? With CSS style sheets. when it encounters the tag, which is meant to, it says, I'm including this, the browser goes out and it fetches the resource and then it processes it. Now, this is kind of like your first pass approximation of how things work. If I were writing a browser, I would pre-scan it for other things that I had to load and then go out and load them while I'm loading the DOM. So I would initiate the communication a little bit before actually reaching that element. Although in the case of a script tag and stuff in the head, it's probably not even worth the effort because you're loading doc type HTML and maybe 2 or 3 meta tags, and then you have is that enough time for it to matter? Probably not, right? So, a good approximation is it encounters a script, it goes and gets the script, it pulls it back in, and then it goes through that script in what order?
Depends on.
Let's say that the browser has decided, I am loading this JavaScript right now. How does it load JavaScript?
Send them off bottom.
Top to bottom, that's right. So you should think of an HTML page, because this is true, you should think of it having one JavaScript interpreter session, right? One JavaScript interpreter session. And you should think of loading a JavaScript file as feeding that file one line at a time into the interpreter. The same interpreter that is your console. Right? So you load your files one at a time into the console. This means that if you're loading multiple JavaScript files, they are not different programs. Right? They are run in the same interpreter session. They have the same variable space. Multiple JavaScript files have the same variable space. Normally, within in-class exercises and that sort of thing, we don't often use more than one JavaScript file in class for whatever reason. But if you load 2 of them, variables from the first one that's run can be used in the second, but not vice versa, right? Because the first one comes first, and the second one comes second, right? Does that make sense? Okay. So, server goes out, grabs the script, executes it one line at a time by feeding it into the interpreter. Then when it's finished, it continues executing the rest of the DOM, right? The reason that we use defer tags is in JavaScript, it's often useful to load references to the DOM, something we've done many times, right? But you can't do it if the DOM isn't loaded, right? If the thing is not in memory, if it's still waiting to be parsed, it's not going to be there when you go looking for it if you're loading your script in the head. Right? Now there are a couple of ways to fix this problem. Using the defer tag is probably the best, as it's the fewest number of keystrokes, and that's always what we prefer. As programmers, we always prefer the fewest number of keystrokes. Basically, the reason the defer tag exists, right, is because JavaScript programmers have gotten tired of writing window.addEvent load, addEvent listener load, right? We're tired of that. It's like a traditional tripping hazard for JavaScript anyways, right? Defer tag, there you go. You can't just make that the default function of JavaScript though, because that's going to break a whole bunch of legacy code. Whenever you're making changes like this, you have to be careful not to break legacy code. Yes. So that's why the defer tag exists. Another thing that you could do, which is bad, don't do it, is you could just include the script at the bottom of the file. This works because it means that the JavaScript is loaded after everything else is loaded, which is effectively what you want, right? But we always, always, always want to put all of our imports in the head so we know where to find them, right? It's like a stylistic thing. Yeah, any questions? So that's all of that business summarized. Oh, goodness me. Do you think we should have the break? I think we should probably have the break. Shall we resume this at 10:37? Sounds good. All right. So let it be written, so let it be done.
As for assignment 5,
Yeah.
so I ended up figuring it out myself through trial and error and looking up on like the Mozilla doc, but like this W3 Schools doesn't have anything on post, but Mozilla does. But it was just playing around with what you get back at the post for that fetch request.
Yeah.
And creating a JSON manipulation or JSON formatting and using object calls to reference values.
Yes.
But I don't think that was shown in this, and I think a lot of people might be lost in assignment 5 and how to do it.
That was kind of. You remember how like I went through like JSON before we did Ajax?
Yeah.
That was kind of that was my intention. But yeah, we can connect the dots. So.
Are we recording?
Eh?
Recording?
Oh, yeah, that's a good idea. Oh, we are recording. Yeah. There we go. If we're making a fetch request, and let's say it's a post request, right? It is true that you've got an option here, right? Your option is, how am I choosing to interpret the incoming data, right? .text will work on anything that's character encoded. If you use .json, it's like using text plus JSON.parse. It's like it is text and then it just calls JSON.parse on the incoming text before it gives it to you. So it saves you that step, right? Which is fine. So then response, let's say like in the particular example of the JSON file that we use for the assignment, the upper sort of level of it, the root level of it is an array, right? So the first level of it, I'm talking about assignment 5, the first level of it, you'll want some kind of numerical index, right? Because you're, most particularly for the post request, you'll want to loop over that number, right? Because, you're possibly getting 15 in. It's possible to do cases out for like 3. It's also possible to do cases out for 15. But, I find that like my threshold for wanting to use a loop for something is usually 3 or 4. If I'm doing 3 or 4 iterations of something, it's like, I should probably use a loop for this. So, if this is a variable you're looping over, you then access any of the particular fields, either in this manner. One of those fields is like URL.
Yeah, URL
Name.
URL name. You can access it this way. You can also access it by saying dot syntax, like it's an object. Both of these are acceptable in JavaScript. Now, there is one thing that you can do with this that you can't do with that. This thing doesn't have to just be a string, this can be an expression. So you could, oh, I don't know, you could say, you know, field, you know, 0, field 1, field 2, right? You can express that as field plus some, concatenate some integer I, and you can access things that way, right? That's something you can do with this that you can't do with that. Does that make sense? Yeah.
You could return the name of field 0 in that instance?
Well, field 0 would have some value, right?
Right, but I meant for like, say I wanted to draw the table dynamically, and I wanted to figure out what the header would be, without using regex.
Right. Oh, interesting question. Yes.
So the way I'm doing it currently is I just use regex to split pairs.
For each loops get you there. Here, let me just look up the syntax for it ever so briefly. So, here's one way to do it. It's a for in loop, very similar to Java syntax. As we all know, the thing that Java calls an enhanced for loop is actually a for each loop. So, for
also.
const key in response, say response 0, right? First entry. This would be, again, one of your little, this would be an indexing variable, right? Key is that. So, log field name equals key, log value equals response 0 at key. That's how you get those data out. I think you
also working.
For of also works?
Yeah.
Ah,
I use for.
bloody JavaScript. Can't even decide what its own keywords are. I think object.entries also will give you a list of them. I think I saw that briefly. Nope, that's a different type of for loop, pardon me. There should be a way of, it's like JavaScript object dot keys, something like that. Yes. So if you call object dot keys, keys, that's round brace, response 0, which is the object, that yields an actual honest to goodness array of the strings, which you could also loop over. You know, name series URL, I think those are the keys. You're probably just missing the fact that these are called keys. But yeah, does that make sense?
Yep.
That helpful? Any other questions about anything? Assignment 5 included?
You send a request for like, Steve, like.
Oh, and yeah, please don't change the URL. Yeah, we'll still use Steve's responder script. And we'll use all of Steve's images from a Star Wars collectibles game that literally he's the only person in the world that plays.
Did you start the recording back?
Yes, I did. Yeah. There's some like really weird Star Wars like extended universe Star Wars characters in that set. I don't know if you guys have noticed. I don't know if anybody's like Star Wars. Anybody's a Star Wars person in this crowd, but like, it's like, what on earth are you and where are you from? You weren't in the movies, you know. Yeah. It's a common misconception that I am a Star Wars person because I carry a lightsaber around with me. This is actually the lightsaber Mark II. The first one was a gift from the mechatronics students that I taught at the university, but unfortunately it broke. Probably because they broke into it, tampered with it, and gave it extra LEDs to make it extra bright. But it's actually kind of nice to have like a glowing stick to point at things in a dark room with. I was a little disappointed when this one came and it didn't light up. I expected it to light up, but you know, so it goes. So, CSS then? Shall we talk about CSS? Very good. All right, CSS. What does CSS stand for? Cascading style sheets. So, you know, the treatment that you get of CSS in HTML and CSS, you get the SS, you know, but perhaps not the C, right? Maybe we're not quite sure why CSS is called CSS and not SS, right? Well, the cascading part of cascading style sheets refers to a labyrinthine system of rules that CSS properties use to determine conflict between different properties, basically. So, if I have a paragraph element, right? Let's say I have a paragraph element, and it has an ID, right? And I have two rules. What color is the paragraph?
Blue.
Why?
Because ID is like,
ID takes,
ID takes blue overrides.
Yes. So, yes, IDs overpower elements, right? They're stronger than elements. So, when this conflict is resolved, it's resolved in favor of this guy. Now, here's a complication for you. Let's say I throw that one in. Paragraph gets border 2 pixels solid black. Question. Does this paragraph element get a border or not?
Yeah.
Why? Why doesn't this
Just the colors of.
contradict it?
Because it's the only one that is.
Because that one is.
Right. So conflicts in CSS are evaluated style element by style element, not rule by rule. That's actually an important distinction, right? This rule does not cancel that rule because they apply to the same element. This property overrides that property only. Right? Make sense? So, basically, whether or not one rule overrides another has to do with a metric called selector specificity. How specific is the selector? Right? Specificity is a very fun word to say. But, you know, so selector specificity is calculated by examining what the components of the selector are. So if I have a selector like P, we have elements, classes, and IDs. Right? So if I have just P, I have one element, 0 classes, 0 IDs. Right? How about this one? Div.clickable.
This one element and one class.
One element and one class, no IDs. Let's say I'll put a few more in. All right? How many elements?
0.
0.
It's 2 IDs.
How many classes?
0.
How many IDs?
2.
Good.
0. 0. 1. 0. 2. 0.
3, yeah.
3. 0. 0.
So you can see that's easy to read. It's easy to come up with these numbers once you know that's what you're looking for, right? Now, the way that we examine, the way that we decide conflicts is the first column we look at is IDs. The second column we look at is classes, and the third column we look at is elements. And I may have messed things up. Let me just add one more thing here. We'll put one ID in there. Alright. So let's say that a style element or a style property conflicted between these two rules. They are both applied to the same element. Who's going to win?
The two ID.
This one, right? Because this is a bigger number. Now, how about these two? Who's going to win?
The last.
Big, small.
This one. But that's because we examine the number of IDs. The number of IDs is the same, So we examine the next layer down. 0 and 2. This one wins, so we go with that one. Does that make sense? And that's kind of how the rule goes all the way down. For example, with these two, right? This is the same, this is the same, this has more, so this one wins. Does that make sense? So that's how things work in that respect. It's also important to know that CSS properties are inherited down the DOM. It's not like, I hate web development so much because it's all not Java. It's calling it, so they do call it property inheritance, right? That is the term they use for it. It is a misappropriation of the term. The relationship between DOM elements is not inheritance in the Java sense. It is association in the Java sense, right? Because if you look at the children property of any DOM element, you will find references to the child nodes, right? A paragraph is not a div. A div has paragraphs, right? In the Java, right? We all remember our Java, right? Remember, inheritance is an is-a relationship. Association is a has-a relationship, right? So a div has 3 paragraphs, but a div is not a paragraph, and a paragraph is not a div, right?
Yeah.
That being said, CSS properties are transferred to child objects in a way that intentionally is aping the concept of inheritance. Even though it's not an inheritance relationship, they're still having inheritance-like behavior, right? So if we have a div that has 3 paragraphs, if we apply a background color to the div, that property is automatically applied to the 3 paragraphs, unless a CSS rule writes to them specifically.
Question.
Yes?
What happens if we have 2, what do you call that? Those things that are the same, like same amount of ID.
Oh,
What happens then?
that's a good question. The one that was written most recently wins. So if you have 2 rules that have like the same numbers here, then what it will default to is the oldest one gets kicked out, right? Because style sheets, once again, are loaded from top to bottom, there is an order in which they're loaded, right? So a style sheet that's above another one in the like in the head block, that one, if there's any conflict between that one and this one, the one that's lower will win.
Okay.
Now, you want to know my honest opinion?
Yeah.
If you're having this discussion about a website, you've already done something wrong, right? Like, you should write your CSS rules in such a way that they don't conflict with each other, right? That would be good design, is to not even get into this bloody situation in the first place. But of course, large designs become large and complex. Sometimes stuff like this is unavoidable. But the less of this you have, the happier your life will be, and the less inclination you'll have to go home and kick your cat because you've had a frustrating day at work. Make sense? I don't recommend abuse of smaller mammals. However, we must all acknowledge that every once in a while, you kind of feel like you want to inflict some pain on something, you know? Yeah. It is best to resist such urges to the extent humanly possible, but we should still acknowledge that we all feel that sometimes, you know? So, does that make sense? So, style inheritance, even though it's not really inheritance. Style inheritance, yes? Right? Good? Question?
So it's inheritance in the sense of actual genetics, like it inherits the traits of its
Yes!
parent.
Yes, that's correct. That's a different sense of the word inheritance. That yes, it's picking up the traits of its parent. Yeah.
In that sense, we have the paragraph and foo, and you have color and red. The paragraph would be inheriting.
You want me to do an example?
Yes.
Can I erase the table? I find it kind of displays the structure best if we do this in the form of a graph. Let's say this one has ID food. And let's change this to make that div. Okay? So this rule, let me indicate this with dots. All right? Red, red. So this rule will apply itself to this guy, right? But through property inheritance, it passes this to all of its children, here and here. Now, this rule comes along and says, I am foo, you are now blue. So it overwrites it. So you end up with one paragraph, color is red. This, I would have used the blue marker if I hadn't done all the type, but this becomes blue. But here's the interesting thing, right? That's also the case if the selector here is at the same level of specificity. In fact, I think it's even true if the selector is underneath specificity. Although I'd have to look that up. But inheritance is considered a weak relationship in CSS, right? An explicit rule will undo inheritance, right? I suppose it would still anyways, because these are loaded in the wrong order, but if you put this one up here, right? This one would not overwrite it. Right? So, undoing our dots, right? Let's assume we're doing, you see how this gets complicated and how you should just avoid it, you know? If we're loading this rule first, it's like, okay, well actually, now that it's a paragraph, it targets both of these, so I'm gonna change that. Change that to, I don't know, an H2. There we go. Now it's an H2. There we go. We're executing this one first because I decided so. It applies itself here. Now we execute this rule, right? It applies to the div. The div attempts to pass it on to its children. H2 is a loyal child who takes the trait of its parent, but the paragraph is a free thinker who does not take on the traits of his parents. It bounces off because it's got a rule already that applies just to it.
So, how would the paragraph write itself before if it's not in the div and the div is the parent class?
This is just a style,
In the paragraph, he will be.
So-
So that's the CSS, not the HTML.
this is,
Yeah.
this is CS.
Like when it's reading it, wouldn't the paragraph be in the div?
Yeah, the paragraph is in a div, yeah.
But it reads first before like the trait.
Well, this is actually an interesting point, right? You're right. I'm playing with this as if the HTML was already loaded when we load, as we're loading the CSS. That's actually not true. The CSS gets loaded before the HTML gets loaded, right? That's true.
This is in the head.
But when you create a new element, part of the element creation process is the style calculation. So it's like part of when it loads the paragraph, it's like, okay, I've created the paragraph, create element paragraph, right? Now I'm going to go through all of my style rules, I'm going to filter for the ones that apply to this, I'm going to apply them in order, I'm going to calculate the style, and then I will apply it. If you can actually, like, if you go into the sources tab, you know, in the inspector, you can look at calculated style. And it will tell you what won. And it will tell you what rules applied to a thing and what won out when there are conflicts.
Okay.
But once again, the best situation is to just not have conflicts in the first place. Like, I have talked to, I've heard it said, I've heard like industry people who are in the industry say that like CSS, like it's often kind of like, you know, everybody knows a little bit of it, but like a highly skilled CSS designer, that's like a sought after position, right? Because like the entry level stuff is like, okay, fine, and that's sure, fair, right? But like if you have a really high degree of skill and understanding of the CSS system, that's actually like, that's a rare skill. Rare skills are employable skills. Especially considering, yeah, pretty much every website ever uses CSS, right? So one path to become gainfully employed would be to become truly excellent at CSS. Even just CSS, right? Although you guys are kind of like, if that was going to be your goal, then I would have an inclination towards graphic design in your back pocket, right? Because like part of what you're judged on in CSS is, can you make it look pretty, right? So if you're the type of person who likes to produce pretty things, then then CSS might be a route for you, right? And like at that level, it kind of becomes indistinguishable from programming. Like, did you know you can define functions in CSS?
No.
Yeah, you can define functions in CSS. Like, let's just say that if you were to go out and get a textbook on CSS, that sucker would be thick, right? There are thin textbooks, there are thick textbooks. CSS, I would guess, would be a thick textbook. You guys want textbook recommendations? Yeah, okay. Well, actually, I'm just going to recommend to you a series of textbooks. I have 2 of these personally, and it's like, yeah, no, these are like proper, like, no, I'm tired of fooling around, and I want to be in it. I want to be a professional developer type textbooks, you know. like, these are the type of textbooks that, like, an actual professional developer would have as a desk reference. I've been exploring the series because my rewrite of server-side for Node.js is going to use one of the textbooks in this series. This is the series. It's called Rhinework Computing. The books, the books are on the expensive side, of course, but books are always on the expensive side. They're well worth it. Git, JavaScript, you can tell how, when they turn them sideways, you can even tell like how thick the books are. Look how thick Git is versus look how thick JavaScript is, right? But yeah, these are the textbooks which I recommend. Oh look, DevOps, woo. Hacking and security, Linux, modern cryptography. PHP, HTML and CSS. Ha! What was I saying? That's okay. So that's not as thick as PHP, but that's still pretty thick, right? Certainly not as like Kubernetes is a kind of on the thinner side. So this is the textbook that I bought for Node. It is excellent. It is an excellent textbook. I also have, where is it here? That one. This one on Docker. Yeah. So yeah, these are really good textbooks. I wouldn't buy the one on AI-assisted coding because it's probably still moving too fast for a textbook to be useful. But I showed these textbooks in like my server-side class, and someone asked me the question. Like this was my response to the question. Are there any online tutorials or like any online sources you would recommend for learning these languages? And my response was basically no. Although there's a great deal of good online resource, and for example, just to pick a specific example, Node.js, all of like Node's own documentation is a website. Right? Same thing with PHP. PHP.net, that's your language reference. Your language reference will be on the internet, absolutely. But like relying on reading like tutorial articles, the space has recently become overwhelmingly dominated by chat output, right? AI output articles. These articles are increasingly inaccurate, right? So there's an effect that's going on right now. In my pridefulness, I want to coin a term for this problem. I've been trying to get it popularized. I call it the Ouroboros problem. If you know that, it's a snake that eats its own tail. Very ancient symbol.
Okay.
And oh yeah, there you go. So basically the idea is like AI is producing all of these articles. AI is now definitely ingesting its own output, right? Which means that anything it gets wrong, it takes as the basis for further articles. So over time, we're going to see just an amplification of the errors that it's making, kind of almost like feedback in a microphone system, And so you're going to find that rapidly, any article you find on the internet that's been AI generated is just going to be junk and not going to work. The code examples are going to stop working. right? I've already found that with like, you know, because I used to use these types of articles for like, oh, just give me some reference on how to use this Linux command. It's like, no, it just doesn't even, like, it often doesn't even work anymore, the code examples that they give, right? Because the thing's ingesting its own output, the quality of the information is degrading over time. So, bloody textbooks, all right? We shall do things as they were done in the 1970s, right? With a textbook, it was written by one person who knows what they're talking about, and the information inside is guaranteed to be accurate. That is the price of accurate information. You get what you pay for. All right? So, you know, basically as the information landscape continues to degrade, these are going to be, like if you want to be a professional programmer who knows, who can outperform chat, let's say, you're going to have to go to actual authentic information. That's what I think the trend of the next 10 or 20 years is going to be. So, question?
Yeah, it's not related.
Oh, okay. General, you want me to get back to JavaScript?
Yeah.
Yeah?
I just want to say like set interval, like two set interval inside each other.
Oh, that's a good question.
Recursion, right?
Um,
If we don't like clear the interval, it's creating recursion, right?
Is that recursion? That's my answer. That's my answer to is that recursion. Groaning sounds. So, recursion is when a function calls itself, right? It's kind of similar to recursion, but it's not recursion. So,
Because I do remember I did this in my assignment, and it's like,
yeah.
you know,
Oh, it gets quite confusing, right?
yeah.
Yeah, like, because if you have a set interval where the set interval is setting intervals, then the number of intervals you have running is actually like proportional to the square of the runtime, right? The number of set interval processes you have running increases linearly over time, right? So yeah, it's not really how intervals work. Let's talk about how intervals work, all right? So I want you to imagine in your brains, all right? I want you to imagine a big table, all right? A big table that JavaScript keeps track of. This is a terrible marker. Why do all of my black markers never work? Good grief. Even the blue one is starting to go. All right. It's review season. Can you tell? Because my markers are starting to go. These things are really expensive for how long they last, you know? I would prefer chalk. Anyway, think of it as a table, all right? You have type, timeout, and function reference, right? So when I say set timeout, you know, function f 1,000 milliseconds, think of that as registering it in a table, right? Type is t, meaning it's a one-time event. Timeout is 1,000. Function is f. It's a pointer, right? We then have a big clock, right? The clock is increasing. It's constantly comparing the clock value to this timeout, right? When it hits that timeout, it's like, all right, execute the function, right? If it's a timeout, then it clears the entry when it's finished. Right? If it's set, if it's interval, right? It does the same thing, but this time it's of type I, right? Timeout, you know, I guess you could say like t plus 1000, whatever the t is, whatever the time is when it gets added to the table, right? Time of entry plus 1000, function f, right? Now the difference with an interval is, when it executes that, it's like, okay, now it's plus 2000, right? Now it's plus 3000. So every time it fires, it doesn't delete itself from the table, right? If you throw on here an ID number, right? The effect of clear interval 2 is simply to find the entry in this table with ID 2 and delete it. Right? So, if the effect of this thing is to introduce another interval, right? Let's say it reproduces a copy of itself, right? So we have, let's say ID 0. So we have interval, okay, time is now 1000, right? So it fires this function. This function adds another interval to the table, and we modify that to 2. ID 1, I, also 1000 in the future, calling the same function f. Right? So time increases. We're now at 2000. It goes through the table in sequence, finding all of the functions that have the timeout of this time, right? And it says, okay, oh, actually, I was wrong.
Yeah.
This is actually exponential. So we execute this thing. That puts another one in there for 3. We execute this one. That puts another thing in there for 3. This thing gets up, these two get updated to 3. Right? You see how it's going? So, yes, we have function calls which are causing more function calls, but this is this function is not directly calling itself, right? It's entering it into a table that in the future this function should be called, but it's not like, that's why I made the groaning sound, because it's like, okay, sure, but like, how different is this from like the CPU's function scheduler? It's like, that's not, let's just say it's not classical recursion. Here's an example of classical recursion, apropos of nothing. Function sum of a list if L is equal to empty list, return 0, else return L at 0. Oh man, it's easier with list slicing syntax in Python, but plus call sum on list from 0 to the end of the list. That's Python syntax for it, but That's recursion. That's a very common type of recursion called tail recursion. So if I have like 1, 2, 3, 4, right? Sum is defined as 1 plus sum of 2, 3, 4. This is defined as 2 plus sum of 3, 4. This is defined as 3 plus sum of 4, right? This is defined as 4 plus sum of empty, and that is defined as 0. That's recursion. Recursion is extremely powerful. All of the best algorithms are recursive algorithms. Once you guys get into data structures and algorithms, you will do recursion. You will study recursive algorithms. You guys heard of quicksort? Quicksort. Yeah.
Merge sort.
Merge sort is recursive,
So
quicksort is recursive, yes. All the best algorithms are recursive algorithms. At a certain point, you know, once you kind of pass beyond a certain threshold in the study of algorithms, there's nothing but recursive algorithms after a certain point, particularly once you get to like graph theory. Which, by the way, if you're interested in studying graph theory within this very program, I would recommend Professor Adams's Math of Gaming class. That class should properly be thought of as Algorithms Part 2. That's kind of how he runs it. So if you want like the really advanced stuff, I would send you there. Make sense? Good. Yeah, so not recursion, but still, this is kind of a good review of like how our timing events work. This generalizes to events in general, right? If you just replace this column with like, you know, click as applied to this element, right? It's like when a click happens, it consults the table to see if there's a corresponding event, and if so, it fires it, right? But, yeah.
Can you review callback?
Can we do what?
Callback function? Callback function.
Call what function?
Callback function.
Oh, callback function. Yes. Sorry. That's what this thing is. So callback function is kind of a general term. You can have, you know, has everybody, like everybody in this room is concurrently doing Java or has done it in the past, right? Yeah. So the stuff that we were talking about with mouse events yesterday in Java, that is, you know, you have an event and a callback, right? The callback functions are the function that you call when an event occurs, right? That's just what the term means. It's more normal to sort of think about it within the context of asynchronous functions, asynchronous communication. So, for example, like most commonly, you'll hear the term callback used when you're doing something like an AJAX request, right? When you're firing a network packet off, waiting for it to come back, when it comes back, you fire the callback, right? But that is really just a layer on top of the event system, right? Programming comes in two main flavors, right? You have sequential programming, like Java, and you have event-driven programming, which is most of what we've done here in JavaScript this semester. Most of what we've done is event-driven. Anytime you have event-driven, the function that you call in response to any event you can call that a callback. Does that make sense? Cool. That's an important term, a very important term. Generally speaking, like, people use that term more when it's like there's some kind of like communication protocol involved, but you know, it applies generally. Any other questions? Okay. CSS animation, I think perhaps we've done that to death through the course of your assignments. Anybody have anything you want to see before we, I have just enough time to answer like 2 good questions. Anything anybody wants to see? Anything anybody wants to know? I'll try not to choke to death on my own tea. Oh, everybody's going to get 100% on the exam then?
Actually, for JavaScript, what's the dating for the exam JavaScript?
Oh, the dates?
Yeah.
Oh, that is a good question.
Sorry,
Is it the 14th for this class?
Yeah,
Yeah,
14, I
I
got
see
two.
that.
I've got one on the 14th, one on the 13th, and one on the 12th, personally. Yeah, 14th at 2 o'clock. The room is C066. Have you guys written there?
Yeah.
Did you make a announcement?
I did, yes.
But
The
how-
exam,
I cannot-
it says exam deets,
Okay.
which is short for details, because I want to seem cool sometimes. Yeah. I think that we're kind of getting to the point where anybody who uses the word cool isn't cool, you know? That's okay. I'm a father. I've come to terms with the fact that I will never be cool again in my life.
Too funny.
All I can do is pretend, you know? So, yes, question.
Not really a question to answer, but besides that and Ajax, that's pretty much everything that's going to be on the exam? Roughly?
Yeah. Yeah. Not quite so much breadth of course to cover for this one as opposed to Java. Like, if you think back upon this course, you know, like, I don't know about you, but I kind of feel like this course is somewhat undersupplied with material to cover, you know? Like, we took 2 weeks to do that in-class
Okay.
game demo thing, and that was fine. We had plenty of time for that, you know? So, yeah. Yeah, like, so, okay. Ajax, all right? Be able to work with JSONs, right? Be able to do a GET request, be able to do a POST request, right? If there's one thing that you should put on your cheat sheet, not that I'm telling you what one of the exam questions is or anything, but it's certainly like the sort of thing you should definitely put on your cheat sheet. The cheat sheet is for things that are like long and difficult to remember, right? Such as all of the options you have to set to do a POST request, right? That's ideal territory for your cheat sheet, right? Not saying whether it's going to be on there or not, but if it is and you put that on there, you'll be happy. Right? So yeah, like the Ajax unit, that's really the main takeaways. With SVG, there were a couple of things, like be able to work with SVGs, right? I will expect you to be able to like, well, I mean, you know, if I give you a diagram, can you represent it as SVG? If I give you SVG, can you draw it as a diagram, right? Do you know how the code corresponds to a picture, right? That's like, for me, that's like something that you should probably know about SVG. Certainly, you should be aware of the process by which JavaScript creates objects, SVG as well as plain old HTML elements, right? You know, create element, optionally NS, modify properties, attach it to its parent, right? That cycle, you should know how to do that, right? Yeah. We did a lot of like, you know, this is how you animate something in SVG, so like, you know, short summary of that. If you have some kind of property that corresponds to position or color or something like that, you modify it in increments and write it to the object inside of an interval, and that produces animation, right? Makes sense? Those were really the main takeaways from the SVG unit. The whole point of that unit, though, is like being able to create objects from JavaScript, right? Because that's essential knowledge. I feel like we did a fairly good treatment of JavaScript like language topics. You know, I feel like we went into a certain degree of depth there that was perhaps even unnecessary, although perhaps hopefully useful. I would only add to that, know how events work, but like, for me, I consider know how events work to be like me saying know how variables work. You know, it's like, yes. We've been doing nothing but events for like 3 months or 2 months now. Like, yes, I can make a click event, thank you. It's like know how to define a function, you know. That's so like if I basically have nothing interesting to say about events if I were to do one on the board, right? It's like, get a DOM reference, add event listener, choose the event type, it has to be a string, attach a function, there you go. That's how you do an event, right?
I have
Yes?
a question. Do you find people tend to need the full 3 hours, or do you find some people are able to finish early based on your experience?
Really depends on the group. It really depends on the group. I find that like, if the test is not a Java test, I will normally have people start to leave around halfway through. But like, that's not necessarily like a good thing. You'll have like your like super hyper geniuses that leave halfway through, but you'll also have the people who give up, who leave about halfway through. So it's like, you know, I never know until I open the paper whether it's one category or the other, you know. It's really hard to say. Sometimes with people, like if you give them the time, they'll fill it, you know. Some people are very fastidious about going back over their solutions and that sort of thing, which I actually encourage. Like, if I'm giving you the time, use it, right? But let me just say that I have designed the exam so that you should have time to fully consider the questions. Like it's not, this one's not a speed test. All right, I'm trying to pull out depth of thinking to an extent, which means that the questions are not, it's not a test to see, okay, how much Java syntax did you memorize and can you vomit out as quickly as possible, right? That's not the sort of test it is. It's, do you understand how things work? And I will give you time to think about them. That's kind of the flavor of the test. Question?
Kind of related to JavaScript. Which one do you find has better results, JavaScript or Java's exam? Like, what do you think has a higher overall?
In terms of average, they're about equal. There's kind of like, there's this cluster of courses that we offer that seem to be all of the courses that I always habitually teach. I always get assigned to these courses, but like pretty much any course you see me in has about a 40% fail rate, 40-50% fail rate. So this course, JavaScript, server side as well. I would argue that the only reason I was seeing like a fail rate in server side of that magnitude was because JavaScript and Java weren't doing their jobs, right? So, you know, I hate to break it to everybody, but if you found like Java and JavaScript at the same time to be, you know, a lot, third semester is like now you've got 4 of them instead of 2. So, you know, it's like at a certain point you have to realize that like, oh wait, Java is actually the job I'm training for. Like it's that level of difficulty throughout. So, yes.
Another small question.
Yeah.
Do you have to pass both the Java exam and JavaScript exam?
Oh, that's an excellent question. So for Java, the policy is you are not, there's no requirement to pass any test particularly, but you know, the testing component is 70% of the grade, so you know, the exam is, I think, 40%, so technically speaking, if you got perfect on everything, you wouldn't have to write the exam, right? In this class, in JavaScript, the exam must be passed to pass the course. So, I know, one of the things I've talked about is that this course needs a midterm.
Yeah.
Yeah, but I can't like, it's a change that I'm working towards getting implemented, but like I can't like, we're not allowed to change courses just like drastically like that within one academic year, right? Because that's kind of like, you know, unfair, yeah. But you know, the next group coming up, you know, we can make changes for them. Question?
So for the JavaScript final, because it's like a 25% final, is there a reason it's so low, but it's still a pass-fail test? Like, what was the thought process?
You have to ask Professor Adams. I can tell you the reason that the exam is pass-fail. It's because people cheat their asses all the way through all of the assignments, and it's impossible to catch everybody who's not writing their own code. And this is a problem that goes way the hell back before ChatGPT. This was a problem basically since the popularization of the internet, right? The internet has mostly been a plagiarism tool for most of its existence. But as to why the assignments are weighted so heavily in this course, I believe the reasoning is something like, if you don't make them nice and chunky, people don't do them. But it's like, I don't know, I don't like it when like the reason for something is like something that's psychological, you know, and kind of, because I view that as a form of psychiatric manipulation, you know, which it really is. It's like if your decision is like, well, you know, people won't do this if I don't give it more weight. It's like, well, yeah, but, you know, does it make sense otherwise for it to be that much, you know? Shouldn't that be the main consideration? Shouldn't people have the option of deciding not to do stuff if they don't think it's worth their time, you know? But, so it goes.
I have a question.
Yes?
How many questions will be there in exam?
See, that's the question I never answer. It doesn't matter. The number of questions doesn't matter because I could ask you one question and it would take you 3 hours. Right? Right? I could make that exam at worth 5 marks and it would take you 3 hours. Right? I could also make it worth, you know, 300 marks and it would be a 3-hour exam. It doesn't actually, number of marks, number of pages, and number of questions doesn't actually map to difficulty.
I'm asking because what mark I need to get to pass the exam?
Well, again, you'll
Like
just have to wait and
50%?
see.
Like 50% or something?
Oh, yeah, the passing. If I told you how many marks you needed on the exam, that would be to reveal how many marks it was out of. But yes, 50% is the level for a pass. And honestly, if you get a 49, I'll give you the extra 1 or 2%. You know, I know it's pass fail, and if you come really close, there's a certain amount of the goodness in my heart. I know that a lot of people think that there's just this yawning black chasm where my heart used to be, but there is a heart down in that chasm somewhere. If you come really close to passing, then I will pass you. But the problem is that lots of people have varying definitions of coming close to passing. It's I've often had people who almost every semester I have at least 3 or 4 people in this category who come up to me. It's oh, but I only needed 6 marks to pass. And it's okay, but those 6 marks are 12% of the exam, right? So no, if you got a grade in the 30s range, I can't pass you, right? It's for me the cutoff is kind of a 48%-ish. So you gotta come pretty close to passing for me to think that you came close enough for me to bump you, right? I'm not bumping anybody from 20%. I'm not bumping anybody from 30%. I'm not bumping anybody from 40%, all right? And I am not the sort of prof that gives out marks for free either when people ask for marks for free. If you want marks, you're going to have to prove to me that you earned them. That's how it works. All right? So anybody who's oh, but if I got 2 more grades, I'd get a B. It's well, then you can come in, we can take a look at your exam, and you can try to prove to me that you deserve more than I gave you. And that's how that works. All right? So,
So in the exam, there will be short question or coding question, what kind of?
There will be short answer questions. There will be coding questions. There will be easy and hard questions in both categories. Right? Just because it's short answer doesn't mean it's an easy question. Right? Some of them are a little tricky. All right? Not that I'm trying to trick you. They're just a little tricky. All right? Yes?
You said you're going to give us questions next week for the review. Do you know how many questions you're going to be giving us?
Oh, yeah, I think it's about six questions. They're actually questions I wrote for the winter term that I ended up rejecting and not including in the exam. So they're they give you a good kind of breadth and scope idea of what exam questions from me look like. But obviously, I rejected them for one reason or another. A lot of them were because I had too many CSS questions. So not necessarily representative of content, but of style for sure. Yes?
Kind of going off of that, with the 6 questions you're giving us, are you also giving us any kind of like previous final for the course? We gotta see what it's like, or no?
Well, there is a review document on there already. Unfortunately, I haven't been in charge of this class long enough to have a good, solid like history of past questions. So unfortunately, you got what you got. But W3 resource is an excellent source for additional practice problems for various different things. You have to be a little selective about the topics, right? And keep yourself within what we studied in the course, right? But W3 resource is an excellent source for practice problems. Any other questions? The bag zipping has begun, so I think we're done. Thank you very much, everybody, for your time and attention. Next week, jQuery. Week after that, exam. Study hard. You still have time, but you won't for long.